Welcome back. Now we will discuss about a rating of SI engine fuels, that is octane number. So the fuels differs widely in their ability to resist knock. The rating of a particular fuel is nothing but the measure of anti-knock characteristics with respect to the reference fuels, which are usually a combination of isooctane and N-heptane. So this isooctane offers a great resistance to detonation. Therefore, it is assigned a octane number of 100. In other hand, N-heptane detonates very rapidly. Therefore, it is assigned a octane number of 0. So depend upon this detonation tendency, this octane number is assigned. That is, isooctane has octane number is 100 because it has maximum resistance to detonation, and N-heptane has assigned the octane number is 0 because it gets rapidly detonate. So whatever the fuel you have to use in engine, we have to refer that fuel with these standard fuels because these are the standard fuels, isooctane and N-heptane. So whatever the fuel you have to test it, the percentage of isooctane by volume in a mixture of isooctane and N-heptane, which exactly matches the knocking intensity of a given fuel in a standard engine under a given standard operating conditions, is termed as octane number of fuel. So if you want to check the octane number of any fuel, there is a setup that is standard engine at standard conditions, and we have to refer that or compare the fuel with these standard fuels. So whatever the fuel is there, if that fuel contains percentage of isooctane means if that fuel have the tendency to resist the knock, how much tendency to resist the knock is measured, and that measured quantity is nothing but what? The octane number. So this is nothing but what? Rating of fuel in SI engine. Now next is additives or anti-knock agents. So there are number of agents available in market to reduce the knock tendency by delaying the auto-ignition of end charge. So following additives are used. If we add these additives inside the fuel, the auto-ignition tendency or this abnormal combustion tendency decreases. So first one is tetraethyl lead, second one is tetramethyl lead, that is capital TEL and TML, tetraethyl lead and tetramethyl lead. Again aniline, ethyl iodine, ethyl alcohol, benzene. So these are the number of additives or anti-knock agents nowadays used in SI engines. Now the next point is highest useful compression ratio, that is capital HUCR. What is the highest useful compression ratio? So the maximum compression ratio used without the knocking or detonation in engine, that maximum compression ratio is called as highest useful compression ratio, because if we increase the compression ratio above this, then if the temperature pressure is more and if the knocking takes place, that compression ratio is not useful. So the maximum compression ratio without the knocking or without the detonation, that max compression ratio is called as highest compression or highest useful compression ratio. So this is about combustion in SI engine.